Hello guys, so today we have an AIME algebra problem. The following number can be written as a root 2 plus b root 3 plus c root 5, where a, b, c are positive integers, and we want to find the product of these a, b, and c. So, first thing we want to do is we're given this radical and we're given its form, which is a root 2 plus b root 3 plus c root 5. Let's change the font. Alright, so let's equate the terms. 104 root 6 plus 468 root 10 plus 144 root 15 plus 2006 is equal to, now we're squaring that, so we have to square requested form, a root 2 plus b root 3 plus c root 5 squared. Okay, so now all we need to do is we need to expand our a root 2 plus b root 3 plus c root 5 and then come and like pattern match our left hand side and our right hand side. So what we could do is we could write a root 2 plus b root 3 plus c root 5 and then like do the expansion that way. We know we have 9 terms, so we just like carefully do our multiplication. But let's go through a little trick. So suppose we have x plus y plus z, which is pretty much the same thing, but it actually saves time. So which is actually just x plus y plus z times x plus y plus z. So how can we do this? So we know that we have 3 choices for which term we want to choose here, 3 choices for which term we want to choose here. So we have a total of 9 total multiplications. So first case is we could choose the same term, either x, y, or z. So we get our x squared. So we get our x squared, our y squared, our z squared, or we could choose something different. We can choose x, we can choose y, we can choose x, we can choose z, and so on. And then for every choice here and every choice here, we can easily mirror it by taking that choice here, that choice here, and that choice here. So there's like a mirroring. We can do the first term, second term, or second term, first term. So that comes out to be, we can choose xy, 2xy, we can choose xz, 2xz, and we can choose yz, 2yz. So this is the multiplication. So let's keep this in mind and then expand a root 2 plus b root 3 plus c root 5 in the next page. So we have a root 2 plus b root 3 plus c root 5 squared. So what will this equal? This will just be, let's do the same thing. Our x is a root 2, so we have 2a squared. Similarly, we have 3b squared plus 5c squared. So and then we take these two terms, which is a times root 2 times b root 3, we multiply them, and then multiply by 2. So this is 2ab root 6. This is 2ac, and then 2ac root 10, and then 2bc root 15. So, and then this is equal to the requested 104 root 6 plus 468 root 10 plus, we have 144 root 15 plus 2006. Okay, so now we need to pattern match our left hand side and our right hand side. So we have 2a squared plus 3b squared plus 5c squared, which is completely rational since a, b, and c are integers with no radicals. So we know that this must be 2006. Similarly, we have the 2ab root 6. The only term with the root 6 is 104. So we can conclude that 2ab is equal to 104 or ab is equal to 52. Similarly, we can say, okay, 2ac equals 468, so ac is equal to 234. And then we can say bc is equal, 2bc is 144, so bc is 72. Great. So what we could do is we could prime factorize 52, 234, 72. Or you could note that in the problem, we're just asked for the product of a, b, and c. So we actually have a nice symmetry here. We know when we multiply these three equations, 1, 2, and 3, when we multiply these, we'll get a squared times b squared times c squared. And then you can easily see that. So all we have to do is multiply these and take the square root. So therefore, all we need to find is the square root of 52 times 234 times 72. And now here's where we prime factorize. So 52 is 13 times 4, which is 2 squared times 13. 234 is, let's see, 117 times 2. And then 117 is 39 times 3. So times 2 times 3 times 39. And then 72 is 36 times 2, which is 6 squared times 2, which is basically 2 cubed times 3 squared. So now all we have to do is prime factorize this. Okay, furthermore, we can write 39 as 13 times 3. So let's prime factorize this. 13's go away, we just have 113. So 2 squared 2 and 2 cubed, that gives us 2 to the 6, so we just have 2 cubed after that. And then we have 3 squared, that's 3 to the 4th. So square root, that's 3 squared. So this is just 13 times 8 times 9, which is nothing but 72 times 13. And if we do that, 216, 0, 2, 7, 6, 3, 9, we get 936, and we are done.